Hey guys, today we're going to talk about rational exponents. So first thing you need to know is rational. A rational number is a number that can be written as a fraction. Alright, so we're going to be talking about fractional exponents. So a rational exponent represents both an integer exponent and an nth root. So rational exponent goes here. Alright, so you can write this as a radical, and this is the rational number, okay, the rational exponent. So if we have nth root of a to the m power, that's going to equal a to the m n power. So you are a to the m over n power. So a is your base, it stays your base in both of these, and then the root becomes the denominator. So just remember that the root becomes the denominator here as this is rewritten. So it's kind of like writing a fraction as a decimal, 1/2 equals 0.5. Well, you can write a rational exponent as a radical as well. All right, let's look at some examples. Alright, so I've got 3 examples here, and the first thing we want to do is just write this. This is a rational exponent, so this would be considered exponential, and we want to rewrite this as a radical, okay? So remember, the denominator is the root, so it's going to be cube root of 125. Alright, we can even reduce this if you want. It'd be 125 to the first power, since that's the root right there. Alright, I know that 125 is a perfect cube, if you remember that from the previous lesson. So 5 cubed equals 125, so that's just that rewritten. And so this would be 5 to the first power, which equals 5. So the 125 to the 1/3 power is the same thing as the cube root of 125, so that equals 5. All right, just 2 different ways to look at it, a rational exponent and a radical in radical form. All right, so 7 to the 1/2, that's the same thing as the square root of 7 times the square root of 7. All right, remember, when you have no number here, that means the index is a 2. Now you can put the index as a 2, you can put that index there, but you don't have to. If there's no index, it's assumed to be a 2. All right, so we've got the square root of 7, 7 times 7. These have the same index, so we can multiply underneath. So we've got the square root cancels something squared, and that leaves just 7 for the answer. Alright, so this one, I've got 3 to the 1/2 power, so that's going to be square root of 3, and times. This one's going to be the square root of 12. And again, if we have the same index, okay, square root times square root, we can multiply those, and that's the square root of 36. And we know that 36 is 6 squared. Square root cancels the squared term and leaves just 6. So that's some examples of looking at rational exponents and looking at radicals. All right, the nth root. The nth root of a is a real number m is an integer remember, integer can be positive or negative, and m over n is rational. All right, so we've got a to the 1 over n equals the square root of a. And that means a to the m over n equals square root of a. All right, so I guess this is if m and n, this is just basically saying your m is your power and n is your index. So you need to fill this in. And then up here, this would be, n would be your root, and it would be to the first power. And that equals the same thing if we have n here, and it can be outside the parentheses as well. So m can be a to the m power under the radical, or it can be in parentheses and the whole thing raised to m. So these are just different ways that these are equivalent. All right, again, we're going to look at some examples of how this works with numbers. All right, so we've got x to the 3/8. All we want to do is rewrite that in radical form. So remember the 8 is your index, so that's the little number here, and x to the 3rd power. You could also write that as 8th root of x cubed. So these are the same. It's kind of what we looked at up here, as long as you have the denominator is your index and the numerator is your power. All right, so for this one right here, we're going in reverse. This one is in radical form. So to write this in exponential form, we're going to have x. The power is 2 over 9. If that can be reduced, you would reduce it. But since that does not reduce, then you just leave it as 2 over 9. All right, this one has a negative exponent. So if you remember your exponent rules, if you have a negative, it goes to the bottom and becomes positive. And I can rewrite 1.5 as a fraction. So 1.5 is the same as 3/2. And then if I want to write that in radical form, that's going to be the square root of y cubed. All right, and then sometimes you have to rationalize your denominator. Since you have an irrational number there, you would probably have to rationalize that. But since we don't know what y is, it's just a variable just for practice, we're going to leave it for now. All right, so moving on to the properties. These are all properties that you need to know for exponents. You will see these time and time again, so make sure you review these. So the first property is if you have the same base and you're multiplying, you add the exponents. So same base, you go from multiplication to addition. So here, I don't know why they're using this funny symbol for multiplication, but that's supposed to be multiplication. Let's change that. All right, so same base, we keep the base, and we add the exponents. Since these have a common denominator, we just add the numerators and keep the denominator. Since 5 over 5 equals 1, that's just 9 to the first power, which equals 9. All right, the second one, same base. We're dividing, so you subtract. Same base, you subtract from top to bottom. So 4/3 minus 1/3. 4/3 minus 1/3 is 3/3. Again, 3 over 3 is 1. So that's just 8. Here we've got in parentheses to a power. So that means that power goes to everything inside the parentheses. So if I've got 3 times 8 to the 1/3 power, then I'm going to have 3 to the 1/3 times 8 to the 1/3. And if I want to multiply these because they have the same power, I'm going to have 24 to the 1/3 power. All right, now you've got a power raised to another power, so you multiply the powers. So keep our base. 1/3 times 9 is 9/3. 9 divided by 3 is 3. All right. And you could evaluate that, but right now we're just looking at properties of exponents. All right, so we've got a quotient, which means division, a quotient, a over b to the m power, that equals a to the m over b to the m. So again, that's in parentheses, so everything in the parentheses gets raised to that power. So right here, we would say 5 to the 1/3 and 27 to the 1/3. Now, 27 is a perfect cube, and we know that the 1/3 power now is a cube root. So we're going to have 5 to the 1/3 over 3. All right, this one has a negative exponent. A to the negative m equals 1 over a to the m. The last example we seen before the properties had a negative exponent, and you seen me move it to the bottom. This is why. To get rid of the negative exponent, you put 1 over whatever you've got. So we're going to have 1 over 16 to the 1/4. Since 16 to the 1/4 equals 2, I'm going to go ahead and rewrite that as 1/2. If you don't know what the fourth root of 16 is, just think of 2 times 2 times 2 times 2. 2 to the 4th power is 16. So 16 to the 1/4 power is 2. All right. Let's use our properties of exponents to just kind of rewrite this. So I'm going to rewrite this as p to the 2/3 power over p to the 3/6 power. And since these do not have a common denominator, I have to get a common denominator before I can use the properties. All right, so I'm going to have p to the 6. Oh, I multiplied by the wrong thing. Hold on one second. I need 6 as the denominator, so I need to multiply by 2 instead of 3. All right, so I'm going to have 4 over 6, and then p equals 3 over 6. Now I can subtract. Remember, the property says if you have division, you can subtract from top to bottom. So 4 minus 3 is 1/6. If you don't understand this, then go back to the last one of the, no, not the last property. Let's see. This is actually the second property. All right, so a couple more examples here. This one we're going to have 64 to the 2/3 power and x to the 6th to the 2/3 power. Remember, when it's in parentheses, everything gets raised to that power. And 64 to the 2/3 power is 16. And then x, 6 times 2 is 12. 12 divided by 3 is 4. All right, let's look at one more. All right, so we've got a negative exponent. So right off the bat, I'm going to write 1 over 125 n to the 3rd raised to the 2/3. When I move it to the bottom, the negative goes away. Now I'm going to have 1 over, and let's see, 125 raised to the 2/3 power is 25. And then 3 times 2 is 6. 6 divided by 3 is n squared. So 1 over 25 n squared is the answer to the last one. So this is some examples of properties of exponents. Just takes some practice to get used to them, but if you use the properties, they shouldn't be too bad. If you have any questions, let me know.